Hi guys, and welcome to statistics class. Today we are going to talk about the introduction to probability. As you can see, we have 6 questions that I'm not going to answer right now. First of all, I would like to show you some examples, and then we are going to answer that question, and then you will have a better comprehension about that. But I want to mention it each one. The first one is, what is probability? Second, in probability, what is an experiment? Third, what is an event into an experiment? Number 4, what is a sample space? Number 5, how to calculate the probability? And number 6, what are the axioms of probability? Okay, so let's start with the example number 1 and number 2, and then we are going to back to answer that question and have a brief explanation of each one. Example number 1, roll the dice. As you can see, here I have 2 dice. In that case, we can get 2 different points. For example, here, if you have 3 and 2, at the end, the addition of both will be 5. But the combination that you can do with 2 dice are 2 until 12. So the question is, which number do you consider from 2 to 12 could be the most I get frequently when 2 dice are rolled? So I'm going to do this twice 30 times, and let's see what will be the results got it. Okay, so let's start. Well, we have finished these tryings. Okay, those are the results that we got, and then finally we are going to count the final results. Question, how many 2 do we have? Let's check. We have 1, 2, and that's all. We got 2 times 2. What about 3? Let's see. Anyone? No, we have 1 over here, and that's all. Number 1, just 1, 3. Number 4, we have 1, and that's it. Number 5, we have 1, 2, 3 times. Number 6, no, we got 1 and 2. Number 7, we got 1, 2, 3, 4, 5, 6 times. Number 8, we got 1, and that's it. Number 9, it's 1, 2, 3, 4, and 5. Number 10, we got 1, 2, that's it. Number 11, once, and number 12, anytime. And here I have another number 7. Let's count again. 1, 2, 3, 4, 5, 6. Okay, yes, I got 6. 1, 2, 3, 4, 5, 6, 7. Okay, it was 7. For be sure, let's count. It's 7, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25. And here we have 25 times that we roll the dice. So it means that we are okay. Okay, now let's see the question that we have over here. The first question is, what was the experiment? What do you think about? The experiment in that case was roll the dice. In that case, 2 dice. This is going to be the experiment. Okay, is the action that we did for got some result of something. Okay, So the next question is, how many events did the experiment have? What do you think about? If you consider that we have 25 events, you are wrong. The events depends of the experiment. For example, here the experiment was roll the dice, 2 dice, and then the thing that you did in the experiment was check the first dice, check the second dice, and add it. So how many events do we have? In that case, we have 2 events. 1 per dice. Those are the experiment. And then the other question, the number 3, was, which is the sample space of this experiment? What do you think about? Sample space are the possible results that you can have. And the possible results were those. So the sample space of this, in that case, this experiment, that is roll the dice, I'm going to call that experiment like a R, capital letter. So the sample space will be into this bracket like a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There you are. Those are the possible results that we can have in this experiment. Okay, the experiment was roll the dice. The events were 2, 1 per dice, and the sample space are the possible result that you got. Example number 2, 3 cards chosen. Here I'm going to work with a pack of cards. First of all, I'm going to show you the hearts. You check how many cards with hearts I'm going to have. I have 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. Did you count it? 13. Okay. Then I have diamonds. Let's count it. 2, 3, 4, 5, 6, 7, 9, 8, 10, Jack, Queen, King, and Ace. How many? Another 13. Let's continue with clubs. 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. Another 13. And finally, spades. 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. So another 13. So at the end, how many cards do we have? We have 52 cards. Okay, let's read what the example said. Choose random 3 cards and get 1 with a diamond, 1 with a heart, and 1 with a spade. Okay, let's try, but first of all, let's remember that it should be absolutely random, absolutely arbitrary. Okay, here, try it 10 times and check right if it happened or wrong if it didn't. Okay, so let's start. Remember, it's absolutely arbitrary. I'm going to choose 3. This is number 1. Here I have a spade. 2, I have a diamond. And 3, I have a spade again. So it means that it was wrong. spade, hearts, and club. Wrong. Okay, on the result that we've gotten, never we get 3 cards, one with a diamond, one with a heart, and one with a spade. Okay, we fail, but we are going to explain this information later. We are going to talk about the relation with the probability. The question that I'm interested to answer this time is, what was the experiment? What do you consider was the experiment? The experiment was choose random 3 cards of a pack. This is the experiment. So what do you consider that is the event, or how many events did the experiment have? In that case, we have 3, 1 per card. According with my experiment, I would like to choose 3 cards of the pack and have 3 different types, with hearts, diamonds, clubs, and spades. So the different arrangement that I can do it with 3 different types is diamonds, hearts, and spades, diamonds, hearts, and clubs, diamonds, spades, and clubs, hearts, diamonds, and spades. Think about it. We cannot make another different kind of group of 3 with different arrangement of one type of each one. This is going to be the sample space, and my objective was that I need to take diamond, heart, and spade. In that case, it's this one, but we didn't get. Backing with the principal question that we are going to talk about in this topic of introduction to probability, I have here some conclusion that we made from the examples number 1 and number 2, and that conclusion I'm sure that you are going to understand better because of the examples. Okay, so the question number 1 was, what is probability? The probability is the chance of the occurrence of an event. So probability, in a few words, is the chance that something happened or not. Okay, and that chance is going to be measured through a number that we are going to talk about that in the question number 5. Question number 2. In probability, what is an experiment? An experiment is any controlled repeatable process. For example, in the example number 1, we have an experiment. Throw 2 dice. It was that experiment. And in the example number 2, the experiment was to take or select random 3 cards of a package of cards. Okay, so any controlled and repeatable process is an experiment. Why controlled? Well, because we have exactly the same thing that we are going to repeat. It's controlled because we have only 2 dice over here, and it's controlled because I'm going to take only 3 cards over here. It's repeatable because in the example of the dice, we made the same thing 25 times, and on the example on the cards, we made the same thing 10 times. So that's why is the definition any controlled repeatable process. Okay, in the question number 3 we have, what is an event into an experiment? It is a set of possible outcomes resulting from a particular experiment. In the example number 1 we have 2 events, 1 per each dice. In the example number 2 we have 3 events, 1 per each card. So as you can see, the experiments are for by events. Okay, in the question number 2 we have, what is a sample space? It is a set of all possible outcomes from an experiment. The difference between the event and sample space is that here we have the word all, and the sample space is for all the possible events that we can have. For example number 1, the sample space will represent from 2 to 12, because according with the events you can have the adding of both points in each dice. You can have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12 with the addition of the 2 points, and this is going to be the sample space. In the case of the cards, will be the arrangement or the combination of the 3 possible different type of cards. I'm talking about diamonds, spades, hearts or clubs, and this is the sample space. Sample space will be, so in that case, the all possible outcomes that you can have in the experiment, and not always that part of sample space you are going to have in an event, like in the example number 2. Remember that we have a target to have a specific heart, diamond and spade, and we never got. So it means that the event is in the sample space, but sometimes it doesn't happen in the experiment. Okay, in the question number 5 we start to work with mathematics. We have here how to calculate the probability. Well, the probability is going to calculate very easy. This A is going to represent the event, so the probability for some event occurs is the number of favorable outcomes, I mean the occurrence, over the total number of possible outcomes, I mean the sample space. For example, if I roll 1 dice and I want to calculate the probability to get only number 5, so the number of favorable outcome is just the number 5 because it's the only one that I want to occur. But the total number of possible outcomes, in that case my sample space will be 1, 2, 3, 4, 5 or 6. So in that case the probability to roll 1 dice will be 1 and get 5 will be 1 of 6. In the number 6 we have what are the axioms of the probability, and this is very important and you need to understand all of them to understand better the calculus of probability later in the other class. Remember that the probability is going to measure in values, and the first axiom says that the value of the probability will be always from 0 to 1. If you calculate a probability and you have a negative number or a number more than 1, it means that your calculus is wrong, because the probability is just from 0 to 1. So a lot of times the percentage are used in the probabilities. So in that case it could be from 0% to 100%. So this and this is going to be the same, but the most formal thing in mathematics will be in decimal. For example, if I have a probability for 0.5, it means that the probability will be for 50%. Or if you have the probability of 0.85, it means that in percentage it's going to be 85%. Or if you have from 0.07, it means that the probability in percentage will be from 7%. Okay, so both will be correct, but the more formal thing is this one. So the second number said, what is the probability that one event not happened? Well, in that case it's going to be 1 minus the probability that happened. So it's going to be the complement of the probability of the event happened plus the probability that that event doesn't happen. So in that case it's going to be 1. So that's why the probability of not happening an event, it will be 1 minus the probability that happened. The number 3 is very important, because if you have the simple space, this is going to be something that is going to help you to understand better the sample space, because if you add the probability of all the events and at the end you have 1, it means that you are right, because the Addition of all the probabilities of the events always will give you 1. The number 4 says that the probability that something real is going to happen always going to be of 1. For example, in a dice, if I want, well, the probability that happen 1, 2, 3, 4, 5, or 6 is going to be 1, because we have on the die 1, 2, 3, 4, 5, and 6. So it means that that number exists on the die. But here we have the probability that something that doesn't exist is going to be 0. For example, what is the probability to roll one die and get 7? In that case, it's going to be 0, because on the dice the 7 doesn't exist. It was all about the introduction to probability. Remember, it's very important to understand what is the probability, to have a comprehension about the target of, to identify the experiment with its events, and to know what is the sample space that you can have. Through the sample space, you will know if the probability calculus will be right or not, applying the axioms of the probability.